Hello students, we are in 12th exercise problem of chapter 10 wave optics. The question is, explain how the corpuscular theory predicts the speed of light in a medium, say water, to be greater than the speed of light in vacuum. Is the prediction confirmed by experimental determination of light in water? If not, which alternative picture of light is consistent with the experiments? So earlier in Newton's era, it was believed that speed of light is more in denser medium like water than that in vacuum. Means if in vacuum speed is 3 lakh kilometer per second, in water it is more. And later we found out that it is not so. In vacuum, the speed of light is maximum, and in all other mediums, speed is less. So, what was the basis for the argument that speed of light in water is more, according to corpuscular theory? In corpuscular theory, it was believed that when the light ray hits any surface, say this black line is surface separating two media. Here we have water, and the red line is indicating a light ray. And let me draw normal also. So this is the normal, and let this angle be I. So it was believed, according to Newton's corpuscular theory, that when light ray hits the surface, its horizontal component remains same and vertical component increases because of attraction of the surface molecules. So if the vertical component is this much, in water it has to be more. And if the horizontal component is this much, in water it should remain same. So now if I draw the vector in water, it would come out to be something like this, and this is the R. So now if you take, we know that this distance is covered with speed c, so the distance has to be ct, and this hypotenuse is vt. And as the horizontal components are same, let them be denoted by x. So I can say that x is equal to x, horizontal components are same, and if we apply sine of I is x by ct, whereas sine of r is opposite upon hypotenuse. So compare this, what you will have, c sine I is equal to v sine r. Okay, and now if I divide both sides with both sides with v, c sine I is equal to 1 sine r, and we know that sine I is less than sine r. Actually, we don't need to divide. Let us drop this step. Now, from figure, we know that sine I is less than sine r, and hence we can say that C has to be greater than V. Mm, wait, sorry, I'm mistaking. As from the figure, we can see that sine I is greater than sine R, and hence C has to be less than V. Okay, but experimental results don't support this. We know that C is more than V by experimental result, and hence the argument put forward by corpuscular theory was wrong. Instead, if we take eta of vacuum sine I is equal to eta of water sine R, then what we get is V is velocity in vacuum, Vw is velocity in water, and we know that this is going to be 1, but yet I am continuing with it. So what we get here is Vw sine I is equal to V velocity in vacuum sine R. And now if I say that sin I is greater than sin R and consequently VW has to be less than V vacuum. This is in line with experimental result, and hence this is true given by wave theory, and this argument fails to support experimental observations. Thank you.